What I'm going to do here is I'm going to solve a non-homogeneous second order differential equation. This time though, in this example, I'm going to do one with a trigonometric particular integral. What I want you to do, read the question, pause the video, have a crack at it and come back and check what you've done with what I'm going to present to you here. So, here you go. So what I want you to do is find the general solution to this differential equation given here. So d2y by dx squared minus 4dy by dx minus 5y equals 30 sin x. Pause the video and have a ping, then come and check what you've done. So what I need to do here is, first thing we do is we get the complementary function. And in order to get the complementary function, we make this a homogeneous equation by doing d2y by dx squared minus 4dy by dx minus 5y equal to 0. Use that to get the auxiliary equation, which in this case would be m squared minus 4m minus 5 equals 0. I solve it to get my roots, and I can make my complementary function from that. So solving this gives me m minus 5, m plus 1 equals 0. So from that I know that m is equal to negative 1 and 5. So I can take this and tell you that my complementary function is y equals a e to the minus x plus b e to the 5x. Now again, remember, it doesn't matter which way around we put the exponential functions. I could have a e to the 5x, b e to the minus x. A and b are just arbitrary. Doesn't matter which way we write them. Then we want our particular integral. So we now need that in order to be able to write my final solution for this, again because it's inhomogeneous. So what I'm going to do is I'm going to take something that gives me this format here. Now it's 30 sin x, so it's going to be a trig one. What I'm going to do though is we have to remember not just to take a sin x, but include the cos in it. So plus b cos x. Because it's a trig one, we're going to look at combinations of sin and cos. Now the reason we do include both is that as you do your working through, you'll find the coefficients of sin and cos both include a's and b's, which will give me pairs of equations to solve for two variables, the a and the b, and then I can get my solution from that. And it will just cover every single possibility we've got. So calculate my derivatives, dy by dx, that equals a cos x minus b sin x. Second derivative, so d2y by dx squared, that equals negative a sin x minus b cos x. And now what I can do is just stick this all together using this equation. So my second derivative, I've got minus a sin x minus b cos x. It's then minus 5 times the first derivative, minus 4 times the first derivative. So multiply all this by negative 4. I've got minus 4a cos x plus 4b sin x. I'm going to run out of room here. It's then minus 5 times the y, so minus 5a sin x minus 5b cos x. And that is going to equal 30 sin x. So what now to do is group all the sines and group all the cosines together. So if I look at the sines, I've got a minus a, I've got a 4b, and I've got a minus 5a. So what I'll end up with is 4b minus 5a times the sin x, take the trig part out as a common factor. I've then got plus, so I've got a minus b, minus 4a, and a minus 5b. So that gives me minus 4a minus 6b. So let's take that out and make it a minus actually. So I've then got minus 4a plus 6b cos x. And I know that is 30 sin x. So if I equate coefficients, 30 sin x is the equivalent of 30 sin x plus 0 cos x. So what I can say from that is negative 5a plus 4b equals 30, and 4a plus 6b equals 0. So what I've now got is I've got a pair of simultaneous equations which I can solve in order to get my solutions for A and B and then be able to put them back into the original equation. In order to do it, I'm going to do what I would normally do for any pair of simultaneous equations. I'm going to scale them to get rid of a variable and solve for the secondary variable. So what I'm going to do in this one is I'm going to multiply the top equation by 4 and the bottom by 5 so I can eliminate the a's. If you chose to do it the other way around and multiply top by 6 and bottom by 4 to get rid of the b's first, that would be perfectly fine. You'd be more than welcome to do that. You would just eliminate b and find the a first. Either way, you have to find both of them. Doesn't matter which order we find them in. So if I were to do that, so multiply top by 4, bottom by 5, what I'd end up with is negative 20a plus 16b is equal to 120, and then I'd also end up with 20a plus 30b equals 0. So now that I've got that, to eliminate the a, all I'm going to do is add the two equations together. So I'll end up getting is 46b is equal to 120. So I can say from that that b is equal to 120 divided by 46, which then simplifies down to 60 over 23. So there's my value for b. What I do is I now plug it into these equations or the previous versions of it in order to get a. So what I'm going to do is I'm going to take the equation minus 5a plus 4b equals 30. So from it, I can say that 5a is equal to 4b, take away the 30. Now b is this 120 over 46. From that, I can say that 5a is equal to 4 times 120, so 480 over 46. Take away 30. Calculating that, that means that 5a is equal to negative 450 over 23. Divide through by 5. What I then end up getting is that a is equal to negative 90 over 23. Nobody ever said the numbers at advanced higher were nice. So what that now means is I've got the coefficients of my particular integral. I now also have my complementary function, so I can combine the whole thing together and say fine, therefore y is equal to my complementary function, which is a e to the minus x plus b e to the 5x, plus then my particular integral with these values put in. So it's then minus 90 over 23 sine x plus 60 over 23 cos x. So there you go, a nice fun one to do. The trig adds an extra element of difficulty to it, but it's not something we can't overcome. We're still able to do it, still follow the exact same steps. Our algebra skills are tested, and so are our numerical skills, no doubt about that, but we're still able to do it in the exact same manner.